Hello everyone, today we are going to solve few important basic conceptual questions, physics questions from JEE Main 2025. Okay, so first question is that find out the equivalent capacitance for the situation shown in the figure. Okay, so before solving this problem, we can proceed step by step to understand it properly. Okay, these are two plates, this and this K1, K2, K3 are dielectric constant of three capacitors, okay, present inside the parallel plate capacitor, and area of each plate is A and difference between two plates is D. Distance, not difference, distance between two plates is D and area of each plate is capital M. So before solving this problem, we are going one step by step. So for capacitor without dielectric, electric field inside the capacitor is this, from positive charge to negative charge. And for, okay, if two dielectrics of dielectric constant K1, K2 are present inside two plates in this way, and we can analyze that the boundary between two plates or two capacitors are parallel to the electric field, and electric field passes through dielectric 1 or dielectric 2, and the most important thing is the boundary between two plates, okay, are parallel to electric field. So we can say that these two capacitors C1 capacitors or capacitance C1 C2 are present in parallel combination, and potential difference between two capacitors are same, okay. And then this is the one plate and this is the other plate, and if two dielectrics are present in this way, if the boundary between two dielectrics are perpendicular to electric field, then we can say that these two dielectrics or two capacitors are present in series combination, and electric field passes through Q1 dielectric first and then K2 dielectric, okay. So these are the main two concepts. If you understand it properly, you can solve the main problem easily, okay. So main concept is that if boundary between two dielectrics are perpendicular to electric field, then we can say that two dielectrics of capacitor C1 and C2 are present in series, and if the boundary between two dielectrics are present parallel to electric field, then we can say that the two capacitors C1 C2 are present in parallel combination, okay. So from this we can see that boundary between two capacitors C1 and C2 are perpendicular to electric field. Electric field line is from positive charge to negative charge. So C1 C2 are in series, and the equivalent capacitance coming from this C1 C2 is situated in parallel combination with C3. Why? Because the equivalent system or equivalent capacitor, the boundary between this C3 capacitor and this equivalent capacitor coming from C1 C2 are parallel to electric field, then we can say that this whole system will be like that, and then the rest of this is just calculation, okay. The C1 C2 are present in series, so their equivalent capacitance is that, and this C equivalence and this C3 are present in parallel, so that is the final answer, okay. Next question is that a charge of value q is placed at the edge of an imaginary cube as shown in figure. Find out the net flux through the cube, okay. Everyone know that from Gauss law, the electric flux through closed surface is Q enclosed by epsilon naught, where Q enclosed the charge which is enclosed by the closed surface, okay. And we see that this Q charge is not a closed by any surface. So to enclose this charge Q, we need basically 4 cubes. 1 cube coming from this left side, and 2 cubes are needed in the bottom, okay. to enclose the charge q. So then we need 4 cubes to enclose the charge q, and then we can calculate electric flux through closed surface. It will be q by epsilon naught. For each cube will contribute q by 4 epsilon naught. Okay. From symmetry analysis, flux through from each cube. Okay. To enclose the charge q, we need 4 cubes basically here. Okay. ठीक है. Then another question is, a solid sphere of mass m, capital M, radius r, exerts a force F on a point mass. This is the point mass. Now concentric spherical mass m by 7 is removed, and they asked what is the new force. So we can use gravitational force here. I think this is very easy question. We can think mass of each point mass. Okay, 1. So the force exerts on a point mass due to full whole solid sphere of mass capital M will be gm by r square, and when m by 7 amount of mass is removed, then force on the point mass will be gm prime by r square. That is right. That is okay. So this will be 6 by 7 f. Okay. So answer will be f prime will be 6 by 7 f. When spherical mass m by 7 is removed, what is the new force? New force will be 6 by 7 of initial force. Okay. So goodbye.